speaking about our Toll Analyst tool inside of SOLIDWORKS Premium. Toll Analyst is a tolerance analysis tool used to study the effects that tolerances and assembly methods have on dimensional stack-up between components of an assembly. For instance, in this sheeter, it's critical that the knife assembly maintains a certain gap between the blades to maintain proper cutting performance. There are several components of this assembly which contribute to this gap, such as the blades, the holders, bushing, and pins. Toll Analyst leverages product and manufacturing information, or PMI, which is created on the parts with the DIM Expert tool. To minimize stack-up, we will control the location of the holes from the blade mounting surface, or datum A, and choose a press fit tolerance for the bore. In the assembly, a Toll Analyst study walks you through a four-step procedure. First, we will identify a measurement that we want to analyze. In this case, the gap between the upper and lower blades. Next, we identify an assembly sequence. The lower blades are assembled first, then the guide pins, the bushing, the upper blade holder, and finally the upper blade. Next, we identify how each part is placed or constrained on the assembly. Here, Toll Analyst is leveraging the PMI information from DIM Expert. For the blade, there are two placement constraints. We're only concerned about the X, so we'll choose that one. The guide pins are constrained in the holes in the lower blade block. The inside diameter of the bushing to the guide pins. The upper knife block can be constrained to the guide pin OD or ID. We'll choose to constrain the outside diameter of the bushings to the upper knife block to simulate a press fit. And finally, we'll constrain the blade to the upper knife block. In the analysis results, we are presented with nominal measurement, worst case, minimum, maximum, as well as the root sum squared, or RSS. For example, to maintain a proper cutting performance, we need the gap between 0 and 0.25 millimeters. The contributor list states each contributing feature and its percent contribution on the worst case, minimum, or maximum. When you select an item on the list, the dimension or tolerance appears in the graphics area. Double-click it, and we can change that tolerance right here in our graphics area. Here, we will change the position tolerance and then recalculate. We still don't meet our desired results. The upper knife block is now the highest contributing feature. Let's tighten up the position tolerance on this one as well and recalculate. We now meet our desired goal. But what if we consider the float in the guide pins? These close running fits add a bit to the calculated gap, but we are still within our results. Finally, these results can be exported to an Excel spreadsheet to document the tolerance stack-up. This includes the analysis parameters, the measurement results, and the tolerance information for each of the features. Toll Analyst is an essential tool to ensure that the components of your assembly always fit together and meet performance requirements.